Alright everyone, this is the very last virtual video, hopefully, if I can ever get back to school soon. So this is the last virtual video, and this time we are going to finish up chapter 2, and this section is on distances and midpoints. So you figured out how to graph lines and determine where lines are on the Cartesian plane, but now we're going to determine how to find distance between two particular endpoints on a Cartesian plane. So distances and midpoints, we're going to talk about how to find the value that's exactly in the middle, and we're going to find the distance between the two. So let's get started. Alright, so finding distance on a graph, I'm assuming you have seen this formula before. So the distance formula, this is how you find on a regular coordinate plane, this is how you would find the distance right here. x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And that's all under a square root symbol, okay? So this formula you need to memorize. You have to know this formula, okay? So know that formula. This gives you a little bit of description on how you come about with the distance formula. But there's a little bit more of a better description in the book if you're interested in that. So alright, so with this formula, we are going to use this formula already, so memorize that formula. We're going to use the formula to find the distance between negative 4, 2 and 1, 7, okay? So let's do that real quick. So we have our formula, d equals the square root of, let's put this in real quick. So first off, mark off our coordinate plane, or mark off our different points, x2, x1, y2, and y1, okay? So we'll start off with x2. Start off with x2, which is 1, minus a minus 4, because that's our x1, the quantity squared, and then we have, this is the whole quantity, sorry, the quantity squared plus our y2 minus our y1. So 7 is y2 minus y1, which is 2, the quantity squared. Okay? So distance equals, this is the kind of work I'd want to see on your homework as well. So distance 1 minus a minus 4 gives us 5 squared, because two negatives make a positive, plus, well, what do you know? 5 squared. So 5 squared is 25, 5 squared is also 25, so 25 plus 25 equals 50. So we have our square root of 50. Now, we're going to have to simplify the radical. And the way that we do that is we would find a perfect square. What's a perfect square that we could put into 50? 25 goes into 50 two times. So we can split it off into two radicals. 25 square root of 2. Square root of 25, square root of 2. Because square root of 25 times square root of 2 will give us square root of 50. But now we can convert this to a whole number. Because remember, square root of 25 is 5. Square root of 2. Alright? So, that is how you use the distance formula. You're going to be using that quite a bit on this homework assignment. So make sure that you know how to find the distance, okay? Alright, so with that, you know how to find distance, but you also need to calculate the midpoint. Alright? So midpoint formula, this is expressed in the form of an ordered pair with your x coordinate here and your y coordinate here. So you're adding the 2 points together and dividing it by 2. That's what will give you your midpoint, okay? Your midpoint coordinates. So this is a pretty straightforward formula to use. You need to memorize this formula as well. Alright, so find the midpoint. We're going to find the midpoint of this segment here, and then we're going to use it to answer a question regarding this graph, okay? So first off, find the midpoint of the segment with endpoints at -3, 4 and 1, 9. All right, so negative 3, 4. Let's substitute those in. We have x2, we have x1, x2, sorry, that's y1, oops, x2, y2, okay? So, x1 is negative 3 plus our x2, which is 1, and we're dividing it by 2, okay? So that's our first number. That's our first number. And then our second number is going to be y1, 4 plus 9 over 2. All right, so this is our midpoint. We have to solve it. Negative 3 plus 1 gives me negative 2. Divided by 2 is negative 1. And then what's my y? 4 plus 9 is 13 over 2. All right, so we have our midpoint. We have our midpoint. All right, now this one is where it gets a little dicey. You write the slope-intercept form of the equation of a perpendicular bisector of the segment here. So this is a picture of the segment that we were just working with, okay? We're writing the slope-intercept form of the perpendicular bisector, which means it intersects at a perpendicular line where the midpoint's at, okay? We have our midpoint, right? So what would we need to find the slope-intercept form? Because remember, we did this we're going back several sections. This is where we used slope and a particular point to find the slope-intercept form of an equation, okay? So what do we need to find? We need to find the slope, okay? So we're going to find the slope real quick. Remember, slope is y2. y2 minus y1. We have our y2 and y1 here, right? So 9 minus 4 over x2 minus x1. So we're finding the slope of the perpendicular line first of all, okay? Well, of our first starting line, okay? Because this is our line we're starting with. M equals 5 over what? M equals 5 over 4, right? So if our slope for this line is 5 over 4, what's the slope of our perpendicular line? The slope of our perpendicular line is negative 4 over 5. All right? So, negative 4 over 5. We have our slope. We have our point. Now we are actually going to use a particular formula in order to solve this, okay? So, let's do it. This is point slope form, remember? So we're going to use this to find the slope-intercept form of our equation. So y minus, what's our y1? It's our midpoint, remember, because that's the perpendicular bisector. So y minus 13 over 2 equals our slope, negative 4 over 5, times the quantity, x minus our x1, which is minus 1. All right, so let's solve this. First off, I'm going to distribute negative 4 over 5 into everything. So y minus 13 over 2 equals negative 4 over 5x. Probably hear my clicking like crazy. Plus, because two negatives make a... Actually, sorry, that is not correct. Let's erase that. Because remember, minus minus becomes a plus, but then we're putting in another minus to it. So, I'm sure that's very confusing. Minus 4 over 5. So, this became a positive 1. Then we distributed negative 4 over 5 into it. So that is how we got negative 4 over 5 there. All right, now in order to isolate the y, because we're writing slope-intercept form, we need to add 13 over 2 to both sides. So y equals negative 4 over 5 x minus 4 over 5 minus 13 over 2. And if I were to do all the math related to that, I would come up with the solution y equals negative 4 over 5x plus 57 over 10. Because I'd find a common denominator first, and then I would multiply the numerators by the value I multiplied the denominator by, and then I'd write it in slope-intercept form. So y equals negative 4 over 5x plus 57 over 10. So you can tell that the midpoint formulas, the distance formulas, and slope-intercept form goes hand in hand. So for some of these particular situations, you're going to need to know how to find the perpendicular bisector for some of these problems. So keep that in mind, and as always, you can rewind the video if you had some confusion understanding this description. All right, we can also take the distance and midpoint formulas and apply them to space. So we can basically pick any 2 points in space. Say I had 1 point here, another point here, like 1 point here, 1 point here. We can find the distance between these 2 points in space. Although it's three-dimensional, you can find those 2 different points. That's what's being illustrated in this graph I have labeled here, right here. This is a 3D, so we could plot the distance from the sun to the earth using this formula right here. So this just adds another element to the distance formula and makes it three-dimensional. Instead of two-dimensional like the coordinate plane, you're going three-dimensional now. Same with the midpoint. So that can be accomplished if we just include the z-axis. I know some of you are fans of Minecraft. If you ever played Minecraft, you know we have x, y, and z. That's because it's 3 dimensions, and it shows you the particular points you're at in that 3-dimensional space. That's what we're doing here as well. All right? So we are finding the distance between the 2 points. All right. So for this one, we're going to find the length of the segment with endpoints 2, -1, 3, and 3, 5, 1. So we have 3 things to deal with here. We have x1, y1, and z1. And we have x2, y2, and z2. So this one might take a little while. Distance. Whoop! Because it's going to be a long one. All right, so we have our x2 first off. Substitute that in. Minus x1, which is 2, the quantity, squared, plus y2, 5, minus 1, the quantity, squared, and then z2. So we add z2 into the mix as well. -1 minus 3, the quantity, squared. All right, so let's put these together. 3 minus 2, the quantity, 3 minus 2 is 1. 1 squared is, well, 1. Plus 5 minus a minus 1 gives us 6. Squared is 36. And then -1 minus 3, the quantity squared. So -1 minus 3 is -4. Squared is 16. All right. So adding those numbers together, we get the square root of 53. We can't really simplify that as a radical, but if we were to use a calculator to change it to a decimal, it is about 7.28. So distance between 2 points in space that we're given here is 7.28. And you can apply that in any given situation. In the real world, in Minecraft, anywhere. This distance formula. All right. So that's actually everything that is part of this topic. Remember, you can always rewind the video if you have questions, or you can always send me an email or a message. Just reach out to me. I'm going to be available. I mean, I'm in quarantine, so what else do I have to do? So come on. So go ahead and send me those questions, and I look forward to hearing from you. So enjoy the rest of your day, and I will hopefully see you all on Monday.